In this lesson, we're going to briefly talk about how to subset SAS datasets. So we want to understand what a data subset is exactly and when it might be necessary. I want you to know the difference between a where statement and an if statement in regard to creating different data subsets, and understand when it's maybe best to use a where statement versus an if statement. So there are many different reasons that you might want to subset an analytical data set. First, one of the more common reasons is that you might be planning to do some subgroup analysis where you're only interested in analyzing the women or the men, or maybe a particular age group, or individuals at high risk or low risk for a particular outcome. Another very common situation where you want to subset the data is if you have a lot of missing data for key variables in your analysis. So for example, you may oftentimes be missing some data for the primary exposure or the primary outcome variable, and when that's the case, oftentimes if you're not going to do any sort of data imputation, you might just want to remove those participants from the data set altogether, so you have a smaller and more efficient data set. This is particularly true when you're working with really large SAS data sets. The larger the data set, the slower the analyses will run, and if you can trim that down a little bit, it can be valuable. Let's talk for a minute about where versus if statements and where exactly these statements apply during the course of an actual data step. This is a visual representation of how data moves through a data step. So usually you'll start with an input data set or input data sets, and most commonly those input data sets or the input data set is specified to SAS in either a set statement or a merge statement. There are other possibilities for specifying the input data sets, but most frequently, particularly in this course, that's going to be a set statement or a merge statement within a data step. And the where conditions operate very early on in the sort of natural history of how observations get processed in a data step. So these input data sets are drawn into an input buffer, and it's at this point where conditions would apply. And from there, the data get further processed and they move into what's called a program data vector or a PDV, at which point the data set, as it's temporarily held in SAS's memory, starts to acquire some new variables, particularly automatic variables and internal variables that SAS creates while processing the data step. From the program data vector, the SAS observations then move to an output buffer, and then finally to the output data set that you're trying to create. The output data set is the actual data set that you specify at the very beginning of a data step in your data statement. So two key points here that I want to reiterate. The first is that where conditions operate early on in the data stream, and they operate at a time point when the only variables available for SAS to operate on are the variables that were contained in the original data sets. The if conditions operate later in the sequence of events, and they operate at a time when you might have new variables created from your data steps, or after SAS has created some automatic or internal variables of its own. And then the data flows all the way through to the output data set. So again, the key here is that where conditions are applied before data enters the input buffer, while the if conditions are applied after data enters the program data vector. Where statements are earlier and if statements are acting later. Therefore, often when it's possible, if you can use a where statement, you should generally choose to do so because it's going to be more efficient and it's going to be faster. In other words, you're taking observations out of the data set before SAS has to further handle them. And that further handling simply takes time and memory. Now don't worry too much if it's not clear to you what exactly the input buffer is or the output buffer or the PDV. That's not of high interest to us. The big point here is the conceptual point about where statements being acting earlier and if statements acting later in the data step. And after we see some hands-on examples, I think it will become much more evident when it's better to use a where versus an if statement. So here's some information in that regard in tabular format that gives some common examples of when it would be helpful to use a where statement versus an if statement, and the situations where you only have the choice of either an if or a where statement. So here in the first two lines, here are two examples where there's really no difference other than efficiency as to whether or not you use a where or an if statement. Either one could accomplish the goal. So for example, if there are existing variables in both data sets that the where or the if statement would be conditioning on or being applied to, you could use either the where or the if. And again, whenever you have a choice, generally you want to use where statements because they're more efficient. Here are a set of circumstances where you must use an if statement. And probably the most common situation where an if statement is required, or the most common situation that you'll encounter using SAS for epidemiological data, is when you want to specify some condition based on variables that are actually created for the first time within your data step. We haven't talked about creating variables yet. We'll be doing that in starting in the next lesson and next set of lessons. But thinking about that conceptually, at some point within SAS you can create new variables, and if you're going to try and subset your data set based on those variables, you need to use an if statement. And then there are some situations where you must use a where statement. When you're using special operators, for example, or even more commonly in the context of SAS for epidemiological purposes, you might do this when you're directly using a SAS procedure and you want to subset that procedure. For example, maybe you want to run a linear regression only among individuals over age 50. You can use where statements to subset that, and we'll see examples of this throughout the course. For more information on this general concept of where versus if statements, there's a nice white paper that was put together, which I've referenced at the bottom of the slide. And I'll also provide this to registrants for this course. The best way to really get a handle on what's going on with where versus if statements and subsetting the data is to just do it in SAS, which is usually the case. So first, let's take a moment here to stop and go through an exercise. You could pause the lecture at this point and try and merge together multiple data steps. We want to merge together the Anthro, BP, BP Meds, and Demo data sets. Name that new SAS data set work.master, so it will be a temporary SAS data set in the work data library, and the actual name of the data set is master. Remember, when you sort each data set, use the by statement and sort by the variable ID, and also use the out equal option to create temporary sorted SAS data sets. It's sort of a good practice to use that approach. And then try to merge only the observations present in all four data sets using the in equal option. So this is review of what we've seen in previous lessons. Take a moment, try and replicate it on your own, and then start back up and we'll move into SAS. I'll show this example again, and then we'll talk about some situations where you would use if statements or where statements to subset SAS data sets. All right, and let's move into some examples. Here we are in SAS. Let's start by just highlighting and submitting my libname statement. Again, this only needs to be done once per working session, so assuming everything worked, which it did, I've now assigned a libref named epic, or in other words, created a data library, and the name of that data library is epic. It's located in this folder on my computer. And then, as we've seen before, the first thing we're going to do is sort each of the 4 SAS data sets that we want to merge by the unique identifier, which is specified by the ID variable in these data sets. So again, we're using the sort procedure, a proc sort. Then you simply specify the name and location of your SAS data set using the data equals option to the sort procedure. And we want to sort the data set named demo, which is located in the epic data library. I want to output that sorted data set into a new temporary SAS data set named work.demo. We're sorting by ID and then include a run statement. And I'm simply doing the exact same thing 4 times over, once for each of 4 data sets. So the only thing that's changing as we go through these 4 different sorts is the names of the SAS data sets that I'm starting with and the new sorted output data sets that I'm ending with. And all of these green comments are simply there to try and put some context around the code if you're replicating this and working with it on your own time. You can quickly double check and make sure that the sorting occurred. Looks like there are no errors and all the data sets were sorted by ID number, so we can come back out of the log file into the editor file. And here's our data step. Now again, data steps start with a data statement, so the very first line of our data step is a data statement right here, followed by the location and name of our new SAS data set. It's going to be a temporary SAS data set in the work data library, and I'm naming it master, semicolon. Then I have to tell SAS where the data are coming from, as you recall. And in this example, I want to merge together the 4 data sets that I just sorted. So there are 4 different data sets that I want to bring together using a merge statement. I want to merge them by ID, so I have my by statement and I specify the name of the variable for which information about the unique identifier is held. And again, that's ID. And then, as we've seen before, in parentheses after each input data set, I'm using the InEqual option to create some new temporary variables that tell SAS whether or not observations are contained within each of these 4 data sets. So if you need to review that, you can go back to the lesson on data steps where we covered that. I'll highlight this, submit it. So it tells me now how many observations were in each data set, and ultimately that work.master has 23,808 observations and 13 variables. Everything seemed to work fine. Now you notice in this example I created the temporary variables here, but I didn't actually apply them. So in this first example, I'm reiterating the point here that you can create temporary variables, but you don't have to apply them. And in this example I didn't. Therefore, if an ID number appears in any of these 4 SAS data sets, it will get merged into the final data set work.master. And as you see, again, we had over 23,000 observations merged in. Now here in the second example, I'm going to actually use the temporary variables I'm creating within the context of the merge statement. And the names of those temporary variables in this example are A, B, C, and D. So I've changed the names just to show you that they're user-defined. Up here I chose to name the temporary variable corresponding to the work.bp dataset in BP. Down here I'm choosing to name that variable simply A. And so those are user-defined. And now I'm actually going to apply them using an if statement, as we've seen before. And what this will do is it will go ahead and create a new SAS dataset, work.masterCommon. It will do that by merging together these 4 SAS datasets by the ID number. and it's only going to merge together each observation if the ID number for those observations appears in all four of the SAS data sets. And since all participants are not included in each data set, because not everybody was invited to all components of the study, we'll have a smaller data set here. You can see Master Common has 15,388 observations, which means we lost about 8,000 observations approximately. So that was our review. And now we'll move forward and show some examples of where versus if statements. In this first example, I'm going to use a where statement because I want to create a restricted or a subsetted data set that only includes younger individuals. And our definition of young here is going to be people who are less than 20 years of age. I'll use a data step. I'm starting with my data statement, and then I'm naming the new SAS data set that I want to create, and I will simply call it work.young for lack of creativity. I'm starting with the existing SAS data set, work.master. So we created work.master up above in the first data step that we ran. And then I simply use a where statement combined with some condition. The condition here is where the variable age has values that are less than 20, semicolon. And as a result, the new dataset work.young will only contain participants who have values of age that are less than 20, or in other words, people under the age of 20. If you jump into the log file and look at that, you'll see there are 10,677 observations that meet that condition. And you can always verify that by using something like proc means, or you can use a proc freak. Here we'll use proc freak, and we'll look at the age distribution in the new dataset work.young. We see we only have individuals who are aged 1 to 19. And there are about 3,000 participants, for whatever reason, in this data set who are simply missing a value for age. That's what the frequency missing down here represents. And now you can also see that if you use an if statement, we'll get exactly the same result. Here, I'm again going to create a new SAS data set called work.young. I'm starting again from work.master, and instead of a where statement, I'm going to use an if statement here in line 64. And we get the exact same result as we had above. Previously 10,677, and here we have 10,677 also. So either a where or an if statement did the exact same thing, and given the size of these data sets, both of them are processed very quickly. So you don't even notice the efficiency issue in this particular example. I also want to point out that in this data set, or data step, excuse me, where I created a SAS data set named work.young, I'm overwriting the previously created SAS data set named work.young. Up here we also created a data set called work.young, and you might have thought it was odd to use the exact same data set name here, and I simply did it because we're going through examples and there was no need to keep separate SAS data sets. So whenever you give an identical name and specify an identical data library when you're creating a SAS data set, if there's already a SAS data set containing that name and in that location, you'll overwrite it. It's no different than saving a Word document in a folder and using a name that's already been used. The difference is SAS won't ask you if you want to replace it, it will just do so. You won't be aware of it. So you need to be careful with the data set names that you use and only write over data sets if that's what you're intending to do. Now in the next set of examples, we'll talk about a situation where you need to use an if statement, and only an if statement will work. And this example actually is exactly what we did above previously when we used these temporary variables created in the in equal statements, within the context of our merge statement, and we applied those using an if statement. So you have to use an if statement in this situation because the temporary variables are created in the program data vector. Therefore, this happens, the where statement, as you recall, happens before the temporary variables are even created by SAS. So the where statement simply won't work. Okay. I won't run this again because you've seen this. It's identical to what we ran above. But as an example, I'll quickly run the code using the where statement, which is incorrect, just so we can see the log file. And we get errors, and it simply says variable A is not on file work BP, work anthro, work.demo, or work.bp meds. And that's because the variable hasn't been created yet. It's only intended to be created for work.bp, but it hasn't been created yet. And then we never even intended for a variable named A to be in any of the other data sets. So when SAS got to that first condition of where A, it's simply saying it doesn't appear in any of the SAS data sets, and then it stops processing. It doesn't go any further and tell you that B, C, and D are also variables not present in these data sets. Here's an example where a where statement must be used. And the example here is when you're using a procedure. So within the context of procedures, you can only subset using a where statement. If statements can't be used. So this will give us the proc means. We'll run a proc means on the dataset work.master, and I want to look at the mean value of age specified here in the var statement, and I want to do that where region equals 1. Or in other words, when I submit that code, I will get the mean age for participants who are in region 1. And here's the output. There are 4,442 individuals in region 1 in this data set. The mean age is 32, standard deviation, minimum and maximum values. And this general approach can be used in any procedure that you use in SAS. As we move forward and talk about ANOVAs and t-tests and linear and logistic regressions, you always can use a where statement within the context of a specific procedure and subset in whatever fashion you like. You can also specify multiple conditions. We could say where region equal 1 and sex equal 2, for example, if we want to subset to a particular gender within a region, and so on and so forth. And if you tried to run this using an if statement, you would get an error, and it says the statement is not valid or it's used out of proper order. This is a very generic type of error that you'll see frequently in SAS, and as it says, it's simply alerting you to the fact that the statement is not valid in the context that you're using it, or maybe it's just being used out of proper order. So in this example, we know we can't use if statements and proc means, and therefore we would have to figure out a different approach to getting this subsetting. And that approach, of course, is to use a where statement. So another situation or circumstance where it's helpful to subset is within the context of data steps, as we saw above, and it's possible to subset based on multiple variables, as I alluded to in the example for proc means previously. I'm just quickly going to use a proc contents and remind myself of what variables are in all of these data sets. So this final merge data set contains all of these variables, so we have that information at our disposal if we wanted to use it in determining the correct variables for subsetting. And you might want to look at some descriptives for variables in the data set, so you could use a proc means or a proc freak or various other procedures. So far we've talked about proc means and proc freak to look at the values and the distributions of various variables and then use that information to do some further subsetting. So based on the proc contents, we'll just use an example where we want to look at distributions for age, diastolic and systolic blood pressure, height and weight, and I'll look at that in a proc means and in a proc freq. Start with the proc means. So here we see 15,388 observations in this data set. The mean age is about 41, and those ages range from 12 to 75 years. The diastolic blood pressure mean is about 83. And here you see the range from 25 to 888. Something seems wrong here because 888 is not a valid value for diastolic blood pressure or systolic blood pressure. So by looking at these descriptives, we can see there might be a problem and we may need to do a little bit of cleaning and QA. We'll come back to this issue. And the height and the weight, these values look reasonable. The height is in centimeters and the weight is in kilograms. So let's take a look at this from a different perspective using a proc freq. So we'll get variable distributions for all four of these variables. So this again simply shows you the distributions of age. For example, there are 352 people who are 12 years old or who have a value of 12 in this data set. They represent 2.2% of all the observations in the data set. And then you have the cumulative frequencies and cumulative percents running over in the last two columns. And that all looks reasonable. But what I'm really particularly interested in here is to look more carefully at the blood pressure distributions, particularly the high end of the distribution where we had those 888s. And here you can see for the diastolic blood pressure, we go from a value of 180, which is high but plausible, all the way up to a value of 888. And it's not just one person or two people with this value, which might suggest a data entry error, but there are about 50 individuals who have values of 888. And what's happening here is that as a part of the actual data entry and data management protocol in these NHANES data that we're using, individuals who could have had a blood pressure measured but who were unable to have it measured the day of the examination for whatever reason, were assigned a value of 888. And as a result, it's good to catch these types of things so we can remove those observations from a data set before analysis because they're not valid and meaningful values for those variables. And if we look at systolic blood pressure, we see the same thing. About 45 individuals who have a value of 888 for systolic blood pressure. And then the heights and the weights, you could scroll through and look at these distributions as well. I'm going to skip over that now. So let's take that information into a data step and do a little bit of a modification. Now in this data step, I'm again going to be creating a new SAS data set. In this example, I'm going to name it Master 1. I want to merge together 4 SAS data sets. I only want to merge together observations that are common to all 4 SAS data sets. So I want to make sure that they have data on, they exist in the blood pressure data set, the anthropomorphic data set, the demographic data set, and the medication data set. I'll merge them by ID. And then I'm going to apply these internal variables A, B, C, and D in the if statement. And in addition to that, I'm going to add a few more conditions. I'm also going to say that they should only be, observations should only be merged together and sent to the output SAS data set if the age variable is greater than or equal to 20 and systolic blood pressure is not equal to 888 and diastolic blood pressure is not equal to 888. This circumflex simply means it's a negation, it means not. And then I'll also pick up this proc freq at the end so that we can look particularly at our blood pressure distributions and make sure that they now are excluding the 888s. So we look in the log file, everything seemed to work. We have 12,765 observations. I'm going to jump to the beginning, scroll through quickly to the high range of the diastolic blood pressure, and you can see now the highest value is 180, and the 888 values were simply removed from the data set altogether. And the same is true for systolic blood pressure. The high value now is 270. There are no more 888s in the data set. This is just a reminder. I wanted to make it very obvious and put it in the slides that you can subset procedures, but when you're subsetting procedures, again, you need to use a where statement. If statements will not work. So in summary, the point here was that it's often necessary in epidemiological analyses to subset your data. That can occur, the subsetting can occur both in data steps or in procedures. And in many situations, both if and where statements give the same results, but this is not always the case. And when it's not the case, you generally want to defer to the where statement because they're a little bit quicker and more efficient.